Welcome back. We have a question here and it reads, express x plus 6 all over x plus 2 to the power 3 in partial fraction. We have dealt with some questions under partial fractions, but this is a type of question where we have something called a repeated factor as a denominator. For example, if we give you an example here, x plus 3 to the power 3 means that you're going to multiply x plus 3 by itself 3 times, x plus 3, x plus 3. This is what we call repeating factors or repeated factor. Okay, the denominator here is a repeated factor. How do we solve partial fraction of this nature? Well, the rule is you're going to build up the power. So, for example, if I have, let's say, x plus 8 all over x plus 3 to the power 4, then since it is power 4, I have to build up the power starting from 1. How do we do that? We're going to have x plus 3 to the power 1 plus x plus 3 to the power 2 plus x plus 3 to the power 3 plus x plus 3 to the power 4. So if you look at it, we have built up the powers. Since it is to the power 4, we have started from 1, 2, 3 to 4. Okay? Then after this, we introduce the constants a, b, c, and d. Then we can continue solving like the way we have solved previously. So because any number to the power 1 is the same, you will not see most of the time this power 1. Okay? So this is how it is. So what if I have, let's say, x plus 2 all over x plus 3 into x plus 4 to the power 3. Again, here we have a repeating factor. And how do we do that? It's simple. But since in the denominator we have x plus 3 and x plus 4, what I will do first is to say a all over x plus 3. Then for the x plus 4, I can build up the powers. Okay? That will be b all over x plus 4 to the power 1, which is just x plus 4, plus c all over x plus 4 to the power 2, plus d all over x plus 4 to the power 3. You can see that. So I have built up the powers for this from 1, 2 to 3. Okay? So this is basically how you solve problems where you have a repeated factor. All right? Now we will continue to solve our problem here. This is the question before us. Express x plus 6 all over x plus 2 to the power 3 in partial fraction. Solution: x plus 6 all over x plus 2 to the power 3. This is going to be x plus 6 all over x plus 2 to the power 3. This is equal to a all over x plus 2 plus b all over x plus 2 to the power 2 plus c all over x plus 2 to the power 3. All right? Then we have x plus 6 all over x plus 2 to the power 3. This is equal to a all over x plus 2 plus b all over x plus 2 to the power 2 plus c all over x plus 2 to the power 3, then what do we need to do with this? We can multiply the whole of this with x plus 2 to the power 3, right? Here we have x plus 2 to the power 3. If it goes into x plus 2 to the power 3, they will cancel out, so it will be 1. Then 1 times x plus 6 is x plus 6, right? So remember, x plus 2 to the power 3 means multiplying x plus 2 3 times. So this is what is the same as this, x plus 2 multiplied by x plus 2 multiplied by x plus 2. So if you should divide that by this again, which is also x plus 2 into x plus 2 into x plus 2, then that is just 1, all right? And therefore, 1 times x plus 6 will give us x plus 6. So we're going to have x plus 6 is equal to, if x plus 2 goes into x plus 2 to the power 3, what do we have? Let's show that. We have x plus 2 into x plus 2 into x plus 2, which is this. Then we divide it by this x plus 2. Then, which means this will cancel this. So what are we left with? We are left with x plus 2 into x plus 2. So that is what we will multiply with a, okay? So we'll have a into x plus 2 into x plus 2, all right? Plus, if x plus 2 all squared goes into x plus 2 to the power 3, what do we have? So what is x plus 2 to the power 3? That is x plus 2 into x plus 2 into x plus 2. If that is divided by x plus 2 to the power 2 means x plus 2 into x plus 2. It means this will cancel this will cancel this. So we are left with x plus 2 that we should multiply with b, okay? So that will be b into x plus 2, all right? Plus, if x plus 2 to the power 3 goes into x plus 2 to the power 3, that will be 1 times, so 1 times c is c. So usually at this stage, what you can do is to try to make one of these brackets 0 in order to be able to find the other constant. So if at all I want to make this 0, I have to make x negative 2, and the same thing will imply here. I have to make x negative 2, all right? With that, we can be able to find c. So let's start by saying let x is equal to minus 2. In that case, we'll have minus 2 plus 6 is equal to a into minus 2 plus 2 into minus 2 plus 2 plus b into minus 2 plus 2 plus c. So that is going to be 4 is equal to, because we have a minus 2 plus 2 here, this is 0, so it means everything here will be 0. Here, minus 2 plus 2 will also be equal to 0. This is also going to cancel out. So we are only going to have c, okay? So therefore, c is equal to 4. So is there any way we can find a and b? Let's try that out. Now, using x plus 6 is equal to a into x plus 2 into x plus 2 plus b into x plus 2 plus c. Here, if we make x 0, we will still come to the same thing. So what we can do is to go ahead and expand this, okay? So that will be x plus 6 is equal to a into x plus 2 plus 2 into x plus 2, okay? what I did is trying to expand this. Take the first x, multiply by all what you have in the second bracket, then take the plus 2, multiply it again by all that you have in the second bracket. With that, it means you have multiplied everything. So plus b into x plus 2 plus c. So that will be x plus 6 is equal to a into x times x is x squared plus x times 2 is 2x plus 2 times x is 2x plus 2 times 2 is 4, then plus b into x plus 2 plus c. So that will be x plus 6 is equal to a into x squared plus 2x plus 2x is 4x plus 4 plus b into x plus 2 plus c. So that will be x plus 6 is equal to, if I expand, I will have ax squared plus 4ax plus 4a plus b times x is bx plus b times 2 is 2b plus c. All right, so that is x plus 6 is equal to, now let me just try to arrange what I have here similar to how a quadratic equation looks like. We know the quadratic equation is in a form of ax squared plus bx plus c, right? So bring the ax squared terms, that is to bring everything that have x squared together, then you bring everything that has x together, then the rest will be your c. Now I have only one term that is having x squared, right? Which is this ax squared. So that is going to be ax squared, then plus this 4ax and this bx do have x in them, so they form the bx term. So let me bring them together. That will be 4ax plus bx, then the rest will be 4a plus 2b plus c. They do not have x. The quadratic equation, this is the same as the ax squared. This will be the bx and the whole of this will be c because they do not have any x with them. So that is c. All right. So if we do the comparison, we have to compare what we have on the left-hand side of the equation with what we have on the right-hand side of the equation. Okay, so it means that, do we have any x squared term here? We don't. So what does that mean? It means that the ax squared is equal to 0. All right, and so 4ax plus bx will be compared to this. Okay, that is 4ax plus bx is equal to x. So if we factorize x, we'll have x into 4a plus b is equal to x, right? So which means this x will cancel this x, so 4a plus b will be equal to what is the coefficient of x. If there is no number written in front of it, it means the coefficient of x is 1. All right, so which means 4a plus b is equal to 1 can be our equation 1. Then we move to those that do not have x with them, that is 4a plus 2b plus c. Then we can compare that with a number here, that is 6. It means that 4a plus 2b plus c is equal to 6. Okay, so if that is the case, is there anything that I can factorize? No. So but we know that c is equal to 4, right? So if I substitute that, I will have 4a plus 2b plus 4 is equal to 6, which means 4a plus 2b is equal to 6 minus 4. So 4a plus 2b is equal to 2. Let's say if we factorize 2 out, we'll have 2 into 2a plus b is equal to 2. Okay? So if we do that, then it means when 2 cancel 2, then the coefficient will be 1. So we'll have 2a plus b is equal to 1. So this will be equation 2. If I use equation 1 and 2, I can be able to find a and b, right? So using equation 1, which is 4a plus b is equal to 1. And what is equation 2? Equation 2 is 2a plus b equals to 1. So which means in that case, b will be equal to 1 minus 2a, right? For this equation. So that is what I'll try to substitute here. 4a plus 1 minus 2a is equal to 1. So we'll have 4a plus 1 minus 2a is equal to 1. So 4a minus 2a is equal to 1 minus 1. So that is 2a is equal to 0. So if that is the case, if you divide both sides by 2, a will be equal to 0. Okay? So if a is equal to 0, what is b? Using this, b is equal to 1 minus 2a. So that will be 1 minus 2 into 0. So that will be 1 minus 0. So therefore b is equal to 1. You see that? Yeah. So going back to the equation where we said x plus 6 all over x plus 2 to the power 3 is equal to a all over x plus 2 plus b all over x plus 2 squared plus c all over x plus 2 to the power 3. So a is 0, so anything divided by 0, it will be 0. So that will be 0 all over x plus 2 plus, we said b is 1, so that will be 1 divided by x plus 2 all squared plus c, we calculated that as 4, that will be 4 all over x plus 2 to the power 3. Then we're going to have just 1 all over x plus 2 squared plus 4 all over x plus 2 to the power 3, and that answers the question. So this is the answer in partial fraction. Thank you very much for watching this video. If this is the first time of visiting this channel, please like, subscribe, and share the video.